Hi everyone, welcome back to Recitation, and today we are going to go through Unit 2-2, which has to do a lot of conditionals like if, else, and while loop and things like that. So we will start with programming exercise 2-2, then we'll move on to lab 2-2. So it should be fairly simple this week, but let's just jump in. So in programming exercise 2-1, what you've been asked to do is to write a function called all primes that will accept an integer n as an argument, and then this function should use a while loop to create a list, which is important, containing all the prime numbers less than or equal to n, right? And so before jumping into the program, we should be well versed about what is a prime number. And the definition is given in the handbook and over here also, that a prime number is a natural number greater than 1, so not 1, greater than 1. That is not a product of two smaller natural numbers. So to put it into perspective, if we pick a number, let's say 11, well, 11 is a prime number, and we start dividing it by smaller numbers, not 1, because every number can be fully divided by 1 and that number itself, as long as it is a positive integer, and we're only using positive integers as values of n in this case. So we will start dividing that number by all the numbers starting from 2 to 1 minus that number. But very soon you'll realize, and I'll explain, that we wouldn't really have to go up to n minus 1 with this tiny nifty trick, right? So let's begin our codes with, as usual, with the pseudocode first. Okay. So now I already have written down the setup that you should have, like CS177, programming exercise 2-2, your name and the headers that we expect. And then, I'll define the all primes function, which accepts an integer. And I've done that already. And then we'll initialize any variables, and then we'll set up a while loop starting at 2 to create a list containing all the prime numbers less than or equals to n, which is actually the problem statement itself. And then observe the indentations. These indentations are important. Then we'll set up a for loop to test if a number is prime or not by dividing that number every time. Now, if it is prime, then sure, we will add it to the list. If it's not prime, we'll just move on. Okay, so let's just begin. We'll initialize any variables, and as instructed, we actually do need something, and that is the list. So let's make an empty list. So this is the empty list, L. I'll call it L. And now we want to make a while loop containing all the, which will go through all the numbers starting from 2 to that number. Okay, so let's actually have a starting value. Let's call it number. So let's initialize that to 2. And now we'll do while number less than or equals n. We will do this, right? And now inside this, now this is a fun part. So we want to make a for loop that will divide that number and keep on going and decide if it's prime or not. And in order for us to actually do that, there is a way to keep track of if it's prime or not. So I'm going to use something in computer science lingo we call flag. So a flag is like a technique. There are other ways of solving this, but this is like one nifty way that you might find useful, is to use this kind of a logic. So I'm gonna call it is prime, and I'm gonna put a boolean that I'll assume that this number is prime initially, whatever that number is, given by the number n, called number. Now let us start a for loop for I in range. We'll start from 2 to, well, we will divide up to n minus 1, at least for now. So that's why we are keeping it like that. So as per convention, instead of doing it there, let's put it below the line where we actually talked about it. Okay. Now, now that this is here, let's do the division. So let's do if, remember that then we are trying to decide if the number that we are calling the variable number is prime or not. So we are going to divide that. So if number mod, we call it mod, you can call it remainder, but whichever way you find it useful. So, well, we don't need the parenthesis. Let's just move that. So if number mod I is 0, meaning it is fully divisible, then what? Then what happens is, then you already know that this number can indeed be divided by some number that's smaller than that number itself. So you already know that this is not prime. So initially our assumption was, is prime true? But now we just realize that, wait a minute, this is not true. So we are gonna do change is prime to false. Okay. And then you might be tempted to do something like putting an else, because if you have an if, there's always an else. That's sort of the idea. For some reason, my indentation is acting weird. So if there's an else, we do something, but for now, let's just leave it be. Let's do if it's not divisible, then we'll do nothing. Which in turn essentially means that we are gonna still keep the is prime flag as true. Okay? So if it is not divisible by a certain number that ranges from 2 to n minus 1, then the is prime value never changes. So the is prime value remains true. So take a moment, pause the video if you will, and think about it. Okay. Now that we have written this loop, it's gonna loop and it's gonna spew out our prime numbers. But the thing that we need to think about is every time what's happening. So let's say this number is, let's say 7, and then the loop will go up to 2 to 6, and it'll start to divide 7 by 2. It'll see that, it cannot be divided fully by 2, so this is not happening. So is prime is still true. Now it's gonna divide it by 3. So 7 divided by 3 does not give a remainder of 0. So still is prime remains true. Same for 4. same for 5, same for 6. So essentially by the end of this loop, if the number is 7, then the is prime Boolean value remains true. In contrast, think about another number 6. In case of the number 6, when you start dividing it by 2, the very first step, you figure out like, oh, if prime has just turned from true to false, because 6 can be equally divided by 2, right? All right. So take a moment to digest that, and I feel like it's time we can actually now move to the next step. So now, if it is prime, we append it to the list. So if it is prime, how can we check if it's prime? Because remember, we set up this flag called is prime. We can simply check that. So we can do if is prime equals true. Oops. Then we're going to put it in the list. So L dot append. Oh, L dot append. And we're going to put in which value that we just tested? Number. Okay. And this is gonna go through every time, and it's gonna go up to until the number hits n. But wait, number is not changing. This is not a for loop, it's a while loop, so we will manually have to increment it. So we are gonna do exactly that. And sorry, the indentation was not right there. And so what we do is we will increment number. So number plus equals 1. Finally, we'll simply return the list. So let's do return L. And now let's save it. This should be our function. But, well, if we run it, it's not gonna give us any output right now. So let's just, well, as long as this is your submission, you'll get full credit. But to test it out, let's make a main function. So def main, and then just print out one call to that, and it's called all primes. So we'll just call it, all primes. Let's see, let's go up to 23. And finally, let's call the main function. Let's go ahead and run it. Oh, sorry about that. I had some comments written down for which it just yelled at me. Let's go ahead and run it. Okay. All right. So we just ran into a slight trouble, and that was a mistake on my part. And well, that happens. Let's talk about what went wrong, why we only got the last value. The reason was the range where we were actually doing the math. It shouldn't go up to n, it should go up to a number, right? Because we are trying to decide if this variable number is prime or not. So now let's run it. Let's do 23 again. Let's run module. Okay, let's go. Oops, I put in some extra. So these are the numbers that are the prime numbers. So it's 2, 3, 5, 7, 11, 13, 17, 19, 23, which is right. I threw in an extra print statement, always a good idea for debugging. Now, okay, let's talk about a little optimization. The thing is, so the main logic for figuring out if this number variable is prime or not is actually in this area of the code. And over here, what we did was we started with 2 and we went up to that number -1 and divided them gradually. But the thing is, if you think about the number 10, and if you think about it, and if you're trying to decide if it's divisible by anything below that, 1 is definitely a candidate, 2 is also 1, 3 is also 1. But when you're thinking about 10, what is the largest one except 10 that you can divide it by? It is actually 5. Because nothing beyond 5 can divide 10. It's too large, right? Which is why, even if we simply slash this loop's upper range by 2, and we need an integer division here, because as you've done in one of your previous labs, that the for loop ranges only take integers. So if you do this, it will give us the same result, except it's gonna divide the loop half the times, which is always a good practice. So if we run it, you see, we have the same result. Okay. Except we had one extra thing here, which I misspoke. So we have a 4 there. The reason being, what this number does is it's gonna floor. So if we divide it, let's say 11, then it's gonna make it like 5.5. The 5.5 is going to come out to be actually only 5, which will be a problem. So if you do that, if you simply do an addition, it's gonna fix itself. So let's go. Now we're back to the correct one. No 4. All right. Okay. So that was one way of going about programming exercise 2-1. Or more precisely 2-2. That was a slight typo. All right, now for the big one. Let's start lab 2-2. And I actually have put in the pseudocode already just to get a head start. But the primary reason I'm going to show this in a different manner is so you can think in the lines, along the lines that how can we do it more precisely than or more efficiently. Okay, so let's just begin as usual. So before you begin, carefully review cell chapters 7 and 8. It was mentioned in the handbook, so you should study that as always. And the problem description says, write a program that takes in integer inputs from the user, then analyzes the integer and determines the following. If the integer is a prime number, oops, sorry about that. And the factors of the integer, the sum of the integer's factors and the program is going to continue to loop, prompting the user for integers and terminating only when the sum of the integer factors is greater than 500. So this is one thing we will have to be very careful about. So as usual, the important parts: set up our lab2-2.py Python file. Then we're gonna organize it with comments with pseudocode. These are very important. So the first bit is we will write a function called factors. So we'll write a function called factors that accepts an integer and returns a list, just like what we did right now. But now this factors function will calculate and store all the factors of the number in the list before returning it. All right, so whatever we put in, it's going to give back the factors of it as a list. So before moving on to part 4, let's go ahead and do it. All right, okay. So we have just finished that one. Let's open up. Okay. That was stuff I already had done, but it's fine. So let's start with the pseudocode. And first we have our headers. Now we're gonna have this, we have this number, and that number, we want to figure out the actual factors of that number, okay? And return it as a list. So we are going to initialize a list. So we have written that down, and then I'm gonna check for the factors of the list using a loop. Okay, so let's make, as like last time, let's make an empty loop. Let's do a for I in range. Now here's the fun thing. We can actually do exactly what we did before, but there's a clever way of going about this, and that is what I just noted down before, and that is, instead of writing just a loop, first let's think about what factors are. So whenever we're thinking about a number, let's call the variable a number, think that what is always a factor. So 1 is always a factor of an integer, okay? So we can happily put in 1 as one of the factors. We're gonna sort this later, but 1 will always be there, okay? And again, what's another factor which is a factor of that number? And that is that number itself, right? So we just did some like math to help us figure some small bit out. Now that we know that we have 1 and number itself as 2 factors, let's worry about everything in between. So to worry about everything in between, let's do range. We don't have to start from 1. We can start from 2 because 1 is already there. And we're gonna go up till the number 1 less than the number. And then if we'll decide if this is the factor or not. So let's describe it. Check if I is a factor of number or not? And if so, append it. So let's do if number mod or remainder I is 0. Well, that means it is a factor. So we'll simply append it to the list. Okay, all right. And there's no else required because that's all it does. And then we can simply return the list, but if you look at what it should look like, then you realize that it's actually sorted. So let's just sort this. So let's do L dot sort. That's gonna sort it, and we'll return L. All right. I'm sorry. The thing is, you could have done it without using the clever math technique I did, but it's always like fun doing it in a slightly different manner. Now let's move on to part 4, which is the main function. And the main function should complete the following things. So it should display the description of the program. We'll do that. We'll initialize the necessary variable. So this, starting from here, is the pseudocode. We'll use a while loop and repeat until the sum of the factor exceeds 500. And inside that loop, like this is important, that we need to take the input from the user inside the loop. And the loop condition is as long as the running sum is below or equals 500. And we're going to determine and display the factors of the integer. And for that, we have the function we just made. Now we're going to determine if the integer is prime and display if it's prime or not. And finally, we're going to calculate and display the sum of the integers factors. So this is what it should look like, and that's how we are going to design it. I have sort of set things up. So first we will define the main function. We already have the factors. Now we will do the program description. And in the program description, I have the program talks about like what it does as usual. Then we're going to initialize any necessary variables, and that's going to be the summation, the running sum. Let me call it running sum to be 0. And as long as running sum is less or equals 500, we're going to keep running a while loop inside which we are going to prompt the user for an integer input. So prompt the user for an integer input. So I have done exactly that, which you've been doing for several of the labs. And then determine and display the factors of the integer. And for this, we're going to take help of the function we just wrote called factors. And I stored them in the variable called factor. Just for clarity, let me call it factor list or factors list. And we'll pass in that number. Now, and then we can determine display the factors. So displaying the contents of the list is, well, you could just simply print the list, but that would not show up the way we want it to show up, like with a space there, which is why we're going to do a loop. We will loop through the list, and for that we're let's write a for loop, and let me do it here live. So for I in factors list, print we're just gonna print str because we want a string value of I, and then we're gonna format this later on. Okay, and I actually have the formatted part jotted down. So that all the spaces are kept and everything. And we're gonna look at this part later. So I in factors list, we're gonna print a space, and every time we're gonna just add one. And with the terminating condition, we're just making it a single line. All right, and with an empty print statement, it's adding an extra new line there. We could have done it using dot format and other means, but this is one way of doing it. Now this is going to print out the factors exactly like this, like one and then a space and then the next one and such and so forth. But then there comes the next question, which is the running sum of the factor. Oh no, wait, we also need to now print if this is a prime number or not. Now the thing is, you can do two things, actually three ways of doing this. One is we can make a function, a different function called is it prime, and just simply take our programming exercises logic there, throw it in there and use it, which is a great thing to do. And the other way is, again, take the same logic from programming exercise 2 2, and like this one, and put it in here, but with a twist. So let me show you one way. Actually, I'll show you two ways of doing it. Now think about a number, if it's prime or not. So if the number, okay, let me put it in comments so that I can express properly. If number is prime, then it has two factors, itself and 1. We can actually make use of this information, and we will see one way of doing that. And if the number is 1, then we will print that it is not prime nor composite. And how did I come up with that? Because it's given here, like it's 1. 1 is neither prime nor composite. So this is a special number. And for everything else, if it is not 1 nor prime, then it is not prime. Okay, so like that. So let's make that into code, and I actually have written this. So one way to do it is the way we have designed the factors function. If it comes back with only 2 factors, then you can readily say that, all right, this number has got to be prime. So if you do if length of where did we put the factors listed there? If you do factors list equals to 2, well, then we know this is prime, and we will print as such. And if length of factors list is greater than 2, then we know it is not prime and will print as such. And well, we don't need an else. And then if we see that this number that we are checking, and we're calling it number is 1, then it's a special case of not prime nor composite. All right, so this whole logic, I have actually jotted this down right over here. We check if the length of the factor is 1. So actually we don't need to do this. We can simply check if the number itself is 1. Then this is going to be neither prime nor composite. Now if the length of factors list is 2, which we talked about here, then this number is a prime number. And if it is not, meaning the length of factors list is greater, then this is not a prime number. All right, so that was one way of figuring out if this is a prime number or not, by taking leverage of the length of the factors list. However, you could have done the same math as programming exercise 2-2 to figure this out, okay? All right. Now, we will look at another approach, that approach, the one I just mentioned, but this is the shortcut approach, I would say. But before doing that, let's just wrap it up, because the next part is to calculate and display the summation of the integers factors. So in order to do that, well, obviously we will need a loop, and we already have initialized running some variable there. So simply ignore the comments for now. So even though it's written up, I'm gonna do it again. So we are gonna do running some we can do is one of two things. We can loop through the list, or we can use the sum function. So let's loop through the list. That's more instructive. Let's do for x in L running sum. Let's add x to that. All right. And let's forget about this line. And we'll print out the running sum of factors is, and we're going to format it just the way we want it to factor. So let's do running sum. Okay, I hope everything's working fine. Let's go ahead and run it. All right. So enter the number. Let's follow exactly this. So the first number is 1. So let's put in 1. Okay. We have a problem. That's okay. That's okay. Don't worry. This it could be always a problem. So let's look at the issue here, and we're gonna diagnose that. Okay, so because L was over there, I kind of confused myself into the factors list name because we named it factors list, not L. So let's do that, factors list. And that should fix our problem. Okay. Let's do 1. Okay, so 1 is neither prime nor composite, and the running sum of factors is 2. Okay. And let's go ahead and do one thing. Let's input 2 there. Although I know that's not right, but so 2 is a prime number, which is correct. And it's 4. Okay, so we have one extra thing going on. So let's just terminate this by having a 600 there, and let's diagnose what the problem is. Why we have one extra. All right. Okay. Mm, so in order to resolve this, let's check our code real quick. All right. Let's take a moment to think about this. So in the factors, so what's happening now, so this is actually a good lesson in debugging. So, oops. Sorry about that. Sorry about that. Let's run it and look closely in the problem that we're having. So if we do a 4, then the factors are 1, 2, and 4, which is right. So we don't have any problem there. The only problem we have is with 1. When we do 1, then this is correct. But in the factors, you see that we are getting 2 1s. We don't want 2 1s, we want 1 1. So let's fix that. So in order to fix that, the way we had defined the factors function, for here we appended 1 like by default, which was incorrect because later on, when let's say when number is 1, 2 would have divided 1 and it would like get a 0 there by dividing itself as a, like, you know, like 2 1 divided by 2 gets you, like when it divides itself by 0, that's gonna work out. So 1 is gonna get added there. So that's why the mathematics of this is getting kind of wonky. So if you just do if number is 1, then we append this, else we append the number itself. Now let's run it. Okay. All right, so let's start with 1. You see, now we have just 1. It's 1. Okay, good. Now let's input the number 2. Okay. Okay. Then we have the number 5. The factors are 1 and 2. Okay. Seems like we have. Now let's try 4. Well, 4 is not a prime number, so we have a problem. Let's go ahead and fix that. I think we had an issue with our indentations. Okay. So if it's 1, then we are gonna append 1. And if it is not, then let's append that number and 1, like we talked about before. So now let's run this. Wow, this had been a challenge. Okay, 1 is 1. Okay. Then we try 2. Let's do 2. 2 is a prime number. And the running sum is 4. Good. Okay. Now let's input the number 5. 5 is a prime number. Good. Then let's input 67. Okay, 67 is a prime number, running sum 78. Matches. Good. Now the number 99. Let's do 99. Running sum is 234. Good. The number 250. 250. And that's it. We have crossed 500. And that's that. All right. Now that was one way of doing this. There are other ways of doing this. Let's do one of them. So instead of deciding prime numbers or non-prime numbers based on what we did here using the length of the factor list, we can simply actually do the math from programming exercise, the one we just did. And this is exactly that. Which is if the length of the factor is 1, or we could just simply say if the number is 1, then we'll print this. And if it's not 1, then this whole code is coming from programming exercise 2-2. So we're gonna call is prime true, and then we're gonna loop through 2 till that number minus 1. And if it divides itself, then we're gonna make the flag false, and the loop terminates outside the loop if it's true. This is a shortcut way of saying if this is true, so I'm gonna make it obvious. If is prime is true, then we're gonna print this that it's a prime number. If it's not a prime number. And the rest remains the same. Let's go ahead and run it and see if we get the same thing or not. So this is version 2. So the 1 works out, 2 works out, 5 works out, 67 works out, 99 also works out. Then we try 250. That works out. All right, so those were 2 ways of doing lab 2-2. Well, I'll see you guys soon and hope you have a good week ahead. Bye for now.